our first real kind of geometry lesson into this unit of 3D geometry is what we're going to be looking at. And so we're going to start off by just kind of talking about these 3D figures that you're going to be working with and how you're going to be doing the math with these shapes, okay? Now, the nice part is these sort of group together, okay? But again, language, right? You've got to be able to understand the language when I refer to certain things so that you know what I'm talking about. So let's start with prisms and pyramids. We're going to start with prisms and pyramids, okay? So a prism is a solid. That's what we call these 3D shapes. We call them solids, all right? A prism is a solid that has two bases. So we're going to kind of underline two bases, okay? And those bases, how you identify them, are congruent and parallel planes, okay? They are congruent and parallel planes, all right? Now, hit the brakes. This is where it starts to get confusing already, okay? My kids went outside to play. I took my wife to go see a play. Same word, two totally different meanings, right? Okay? Here you see the word base, okay? And this is going to be referenced to as a capital B base, which is the base of the solid, all right? That's different than the base and height base that meet at 90-degree angles to form, our area type questions. That's lowercase b base. Okay, so when I use the word base, you've got to be able to distinguish, is he talking about the base of the solid, or is he talking about the base line measurement, the one-dimensional base measurement? Base capital B is a two-dimensional measurement because we're talking about the plane base, right? Now, what we're going to do is we're going to highlight our bases so that they stand out to us in our prisms, all right? So here's what I want you to do with one of your colors. We're going to highlight the top of our base. So I like to kind of go around the edges, and then one thing you can do is sort of use like little stripy stripes. And then I'm going to go down here around the bottom of my prism, and I'm going to highlight down here like that. And another thing you could do is you could do like a differing striping pattern like that, and that will help make your capital B bases of your solid stand out. Now you can see that I have two planes. They do not intersect with each other, kind of like the last question on that first lesson. We had these two planes that do not touch each other, right? And they are the same shape. And that's what this word means, of course, is they have all the same measurements. And we're going to get more detailed into what these words mean a little bit later. But you have to understand how to identify your bases. They do not touch each other. So this right here and this plane right here could not be the bases of the shape. Why? Because they intersect. Where do they intersect? They intersect at a segment right here. Okay, do you see all the language that just came from that last lesson that I used in that statement I just made? That's why you have to be able to speak this language so that we can do this lesson appropriately, okay? Now, when we name these bases, just like you have a first name and a last name, most of you, I don't think I have any shares in here, okay? Wow, I just dated myself using Cher. I could use Madonna. What's a one-named artist you guys listen to? Beyonce, there you go. That's a good one, right? Okay, well, these are two named shapes, okay? Their first name is going to be the shape of the planes that make up the base. Their last name is going to be their classification. So in this particular case, what shape are these two bases right here? Those are triangles, right? And what kind of a shape this is that has two bases? It's a... So then first and last name of this shape would be what? No. First and last name. Triangular prism. All right, let's write that down, okay? So this one is a triangular, first name, prism, last name. Okay? First name is the shape of the base, capital B base. Okay? Last name is the classification that it fits. In this case, we have two bases that are congruent and parallel. That makes it a prism. It's a triangular prism. Got it? Okay, let's talk about a pyramid. Notice the difference of a pyramid. A pyramid only has one base. Prisms have two bases. Pyramids have one base. Okay? Now, pyramids also have faces, and those faces meet at a point. Okay? Put your finger right now on this picture where you think the point is that the faces meet. Put your finger where you think the point is that the faces meet. If you put your finger right here, you are correct. That is the point where the faces meet. The faces then would be the planes that narrow in to that point. So this plane right here is a face. This plane right here is a face. The plane on the back right here is a face, which would make this guy down here what? Capital B, base. Let's highlight it. Finding the base is going to base or bases is going to be very important, right? Because if you have one base, now you know this has a different name than the previous one, right? Okay. But again, the nice part is the naming is the shape of the capital B base or bases, and then the classification, first name, last name. What do you think this one's called? Tell your neighbor right now what this one's called. I'm coming to you in 5 seconds for an answer. What's this one? Tell your neighbor. What's this one? I'm coming to you for an answer. Tell your neighbor. What's this one? You got 3, 2, 1, right here. Shh. Max, what's this name? Very good. Triangular pyramid. Exactly. So again, first name is the shape of the base, and then last name is the classification. Okay, so 2-based, 3-dimensional solids are prisms. 1-based, 3-dimensional solids would have faces that meet at a point is a pyramid. Okay? We can have multiple different types of bases, right? So that determines what kind of pyramids and prisms that we have. Everybody good so far? Okay, good. All right, let's talk about a cylinder. Well, this is kind of easy then. A cylinder is just a prism with circular bases. Okay, well then highlight your 2 capital B bases in this cylinder. Okay, highlight your 2 capital B bases in this cylinder. Ready to go. Here's what you should have highlighted for your cylinder. That's pretty easy, right? Yes. Okay. Now, this is your Beyonce right here, right? This is just a cylinder. We don't call it a circular cylinder because there's only one kind of cylinder. It's cylinder, and that's because it has only one kind of base. There aren't multiple shapes. If you have a circular-based solid and it has 2 bases, then it's called a cylinder. Okay? So this is your single-named artist. Got it? See the difference? Okay. Well, then a cone is just a pyramid with a circular base. Well, that's easy. Cone is just a pyramid with a circular base. All right, highlight your base for your cone. Ready to go. You should have highlighted that, right? Everybody good? Yeah. Easy enough? Now, there is another solid on here. We're really not going to talk too much about this one just based on time. I want to focus on some other things. So our conversation is mostly going to focus around prisms and pyramids and some cylinders. You guys will not do so much of the pyramids and the cones. We're going to focus a lot on our prisms and cylinders for us, but you need to know what they are. However, let's talk about it for just a second. A sphere is a 3-dimensional circular solid. Now, what we would call a base-like thing, it's not actually called the base, is like this slice that we take out of our sphere right here that runs directly through the middle. So however you slice that sphere, because it's circular all the way around, it meets that characteristic or definition of a circle. We take a slice out of that, and that would be that base-like shape in our sphere. Okay, everybody good? All right. So here's what I want you to do. You are going to, this word classify right here is name. You are going to name first name and last name, if they have a first name and last name. If it's just a one-name artist, then name a one-name artist. But you're going to first name, last name, and highlight your capital B base or bases for these questions right here. let's see what you can come up with. So you're going to highlight and you're going to name. Highlight and name 1 through 12. Feel free to bounce some ideas off of each other, work with each other, and then we'll come back and take a look and see how you did. Okay? Ready, go.
What?
That's definitely an octagon.
Yes.
That's about as zoomed as I can get. Yeah. You can come up here.
Oh, that's a hexagon.
No, it was just the box. Oh.
So let's talk about it, right? So rectangle, right, is this one here, right? One base, so it fits the pyramid. Cone, one base, circular. Triangular prism, right? Two bases, triangle-shaped bases. Again, the bases have to have the same measurements and they can't touch each other, right? And then you've got, this one fits the pyramid classification, and then we have 1, 2, 3, 4, 5, 6 sides. So if you put hexagon pyramid, I'm okay with that. You can put hexagonal pyramid, that's fine. Okay, if you indicate to me that you understand that it's a 6-sided base, I'm good with that. Cylinder, we've got 2 circular bases, and then rectangular prism we have here. Now, with the rectangular prism, it's a little weird because you could actually say this is a base and this is a base as well. That's a possibility, okay? So in either case, you could call it that, okay? Because those would be, again, congruent and parallel. Any questions on these? Makes sense once you see them. First names, last names, okay? All right, good. All right, let's talk about the bottom ones. How'd you do? Take a look. Again, pentagon prism I'm okay with here. This one's kind of a tricky one, and it's a good one to talk about. So let's talk about this one. Can I zoom in on number 7 real quick? Everybody got their corrections made? Make your corrections. And you know, I like to do them with the colors, but like if you're like, oh man, I messed up and now my paper's messy. If you want another copy, I'll be happy to give you another one. And then you can have a clean one. Just see me after class and I'll be happy to get you another one. All right, let's talk about number 7 for just a second here. Now, you'll notice that I highlighted the trapezoids as the bases, right? Question. Let's talk about this plane right here and this plane right here. Tell your neighbor why those can't be the bases, because I'm going to ask one of you for that answer. This plane right here and this plane right here, you have 5 seconds. Why can't those be the bases? 3, 2, 1.
They're not parallel.
Whoa, Samir, easy, buddy. I didn't call on you. Hang on. All right. I guess we'll let Samir answer that one, and then you're going to have to wait for the next one. All right. What'd you say?
They're not parallel. They'll intersect.
Yeah, they're going to eventually cross up here, right? And so that does not work for those. But these are parallel here, right? This one and this one. Tell your neighbor why those can't be the bases like in the rectangular one. Okay, you have 5, 4, 3, 2, what? Aiden, you think you got it? Shh. They're not the same size. Very good, right? Like this one is clearly smaller than this one. And in order to have the bases, they have to be the same size and they have to be parallel. And so that's what forces the bases to be the trapezoid. Okay? Everybody good so far? Cool. All right, so classifying our shapes. All right, let's get your next paper. Okay, listen up real quick. Everybody right here, eyes on me in 3, 2, 1. Everybody looking right here. Everybody's eyes. Eyes right here. Stop what you're doing, put your pencil down, eyes right here. Everybody's eyes right here. Okay, so listen. One of the things that I notice students have a hard time doing is controlling their pacing, okay? And I'm all about the pacing, all right? because I want you focused on what we're working on and only what we're working on. And I don't want you blowing ahead and not paying attention because you think you know everything already. And maybe you know some of it, and maybe you know most of it, and that's fine. In the end, you'll have an opportunity to do that, okay? So one of the ways that I'm going to control your pacing, because I've asked you a number of times, I've said, hey, there's some things we're going to do together, and then there's some things you're going to do on your own, and then there's some things we're not going to do at all, right? So one of the ways I'm going to control your pacing is I may stop occasionally and just say, hey, quick, let me see your paper because I asked you that we moved on from number whatever, and we're not supposed to have had that one done. And if I come around and you've got one done that we didn't do, that you weren't supposed to be working on, that's going to be a tick off that daily participation grade because you're not following the instructions of the class. Does that make sense? So please only do the questions that we do with here together in class. Stay with me. Don't just be blowing ahead, filling out things and not paying attention. All right? So just focus on what we do. And that's all you got to do is follow the instructions and be a part of what we're doing here in class. And you end up with the full grade. Does everybody understand that? Cool. Easy enough, right? Okay, good. Fantastic. All right. So let's get going on our measuring part of our lesson here. So today we're going to be talking about surface area, okay? And we're going to start with surface area of prisms and cylinders. All right, surface area is like wrapping paper, okay? When you wrap a gift, right? You wrap the paper all the way around the entire outside of the gift. If you unfolded the wrapping paper, that would be your surface area. It's the area that covers all of the surfaces of your shape, all right? Now, some of these are very easy, and some of these are a little bit more complicated, all right? You are going to have a series of formulas that look like this, and that look like this, and when we get to the backside of our paper, we're going to have ones that look like this, and so you're going to need to be able to know what shape goes with what formula. Now, I will give you on test day this, but you need to know what it goes with. So you got to be able to put the name with the formula and whether it's a surface area, and we're going to also talk about volume. So you'll need to know, is this a surface area or volume formula? That you'll have to know, and what shape does that go with? Okay? Everybody got that? All right. Now, there are some common languages that are oftentimes used with these. You can see the length, width, height, the L, the W, the H. Sometimes I will use other language for these, right? For length, I will call that base, right? For width, I sometimes call that depth. Those are some other kind of more older geometry names. Length and width tend to be more grade school-ish, okay? All right, so if you think about this particular shape, this formula is a very logical formula. Okay, it's like the perimeter formula when we were finding the perimeter shape, right? Like, let's just think about, you know, the area of, I'm gonna say the area of this front plane right here. If we wanted to know the area of that front plane, that's finding the area of a rectangle, right? And we would do that by multiplying length times height, right? Length times height. And there are two planes that match that same length times height measurement there, right? And so we have two length times heights. Do you see it? Right? And then we have two length times widths, right? And then we have two widths times heights. Those will be the ends over here, right? And so then by finding the area of one of those, we just double it and we come up with our answers. Easy enough? Okay, this one's one of the simpler ones, all right? So here's what I'd like to see from you in terms of work, okay? I'd like to see something like this, where you say the surface area of this rectangular prism is 2 times plus 2 times plus 2 times That's how you're going to start your problem, like that, with a series of what I call open parentheses. They're places for you to dump in numbers. By the way, that's all a variable is, like in this formula right here, the L's, the W's, the H's. They're just places to dump in numbers. What numbers do I dump in? Well, the numbers that you deem to be L, W, and H, all right? So why don't you try to fill in these missing values in here? Let's just start with getting the missing values filled in before we do all the calculations. That way, if you get the numbers in the wrong places, then, you know, you can go back and fix it. All right, so let's do that first. Go. Then that looks like this right here. Now, The order in which you structured those numbers together doesn't really matter, right? Because 2 plus 3 plus 4 is the same thing as 3 plus 4 plus 2, or 4 plus 3 plus 2, right? That's the commutative property. We can move that around. What is important is that you make sure that you get each set of those measurements that are being multiplied. So what you call length, width, base, height, depth doesn't really matter so much in these problems, as long as you're making sure to get this measurement here, right? And then this measurement here, right? And then the third measurement obviously is that top one there. And so you've got to make sure to get all of those measurements for those 3 sides, okay? Or those 4 sides, okay? Once you have all of those, then you jot them in here into your formula. Everybody good? All right. So then you should have one step of work right here that is this math problem, do this one and then write plus, do this one and then write plus, do this one and then write plus, and then you can write your answer here. So you have one step of work here, and then your answer here. Don't forget your unit of measure. Go ahead, finish it up. Come up with 542 feet squared, right? You get your feet squared because this is an area measurement. It's a two-dimensional measurement, right? It's just a bunch of two-dimensional measurements being added up, right? So this is not cubed because what we're doing is taking this shape apart and we're doing an area and an area and an area and an area and an area. It's a whole bunch of areas, just like it's a whole bunch of x plus x plus x plus x is 4x, right? This is area plus area plus area, or feet squared plus feet squared plus feet squared is all feet squared, okay? Okay, that's easy, right? Everybody good with that one? We don't need to do another one of these, do we? Okay, good. All right, we're going to leave 2 and 3 then. All right, so let's talk about all other prisms. Let's talk about all other prisms. All right, here's where it starts to get tricky, so pay close attention, okay? All right, there are 2 pieces of these all other prisms that we are going to find in order to determine the surface area, okay? One of those pieces is something called the lateral area. This would be the area of the non-bases. The area of the non-bases. All right, let's take this shape right here, and one of the bases obviously is already highlighted for us, so let's highlight the other base. Where is the other base? Because it's a prism, so it's got to have 2 bases, right? Where's the other base in this picture right here? Highlight it right now.
I did it.
Good. So you should have gone, right? There's our other base, yeah? So then what we're talking about in terms of finding the lateral area would be the area of this plane plus the area of this plane plus the area of the back plane here, okay? That's what we're looking for when we're talking about the lateral area. And we have a little formula that helps us find that. It's the height times the P perimeter of one of the bases. Which base? Well, it doesn't matter. They're congruent, right? See, that's the nice part about having the same bases. We can use either perimeter to do that. That's going to help us find the area of these 3 planes right there. Then once we have that, we're going to find, see, so there's our lateral area right there. Then we're going to find the area of one of our bases and double it, okay? And so once we have that, we will be able to figure out the surface area of this particular prism. So let's do one together. That way you kind of see how this works. Okay, so we'll start with number 4, all right? What kind of a prism do we have here in number 4? Triangular. Highlight the bases. Ready to go. Are your 2 bases right here? Yeah? Everybody good? Okay, so let's talk about finding this lateral area. To do that, we need to identify the height of the prism and the perimeter of one of the bases. Now, this is a really important understanding of the word height. In a solid, when we talk about the height of the solid, that is the distance that separates the 2 bases, right? The bases can't touch, right? So they have to be some distance apart from each other, right? So whatever the distance is that separates the 2 bases, that's the height of the solid. Follow me? Okay? So that's what we're looking here for, is the height of the solid. So that's 16 units, right? 16 meters. We're just going to use numbers for now. All right, why don't you come up with the perimeter of one of the bases? Go ahead. perimeter of one of the bases. Go for it. Come up with 36, right? Where does that come from? Well, that comes from 9 plus 12 plus, I don't know that measurement. Oh, actually, I do know that measurement because if I took those and I just collapsed them right on top of each other, they'd be exactly the same size, which means that that must be 15, just like this must be 15, like this must be 9, and that must be 12, huh?
Okay.
See it? Okay. Perimeter of one of the bases. Okay, cool. So then that means that the lateral area is just going to be the height times the perimeter. So you do that. And we get good 576, which ends up going to be meters squared, right? Now look, here's the deal. This number right here represents this area of that plane plus the area of this plane and also the area of this plane. Well, that's kind of convenient, huh? The question I like to ask is why? Why does that work like that? Well, let's take a look at why that works like that, because that's what really makes geometry interesting. So let's just do a little right there. It's not 12. It's 9 plus 12 plus 15, because that lines up with this side of the base. Like if we took those two shapes and just collapsed them right on top of each other, this side right here would line up with this side right here. And that's 15. Good question. Thanks, Honor. Okay, so let's talk about why does the lateral area formula work? Why does the lateral area formula work? Okay, let's talk about this. So the lateral area, we just said was the area of 3 planes, right? It's the area of the front plane. Well, let's just do this. What's the area of this plane right here? What kind of shape is that? 1, 2, 3, 4. It's a rectangle because they're not all the same, right? Okay, so how do I find the area of a rectangle? Lowercase b times height, right? Base times height. So this would be 16 times 15, right? That would be the area of that one. Good? All right. What would be the area of that shape right there? It's also a rectangle, right? So this one would be what? 9 times 16, right? I'm going to write it 16 times 9. 16 times 9, right? Okay. And then lastly, we need the area of that guy right there. What's that one going to be? 16 times 12. You see that? Does everybody see where I'm getting these numbers from? Any questions on where I'm getting these numbers from? Right? One side, the other side, the third side. Now, we can go back to algebra here, and we can do a little factoring by grouping. I could pull out a 16 from each one of these terms. Watch, if I go lateral area is 16, and I factor that out of each one of those terms, what am I left with? Well, I'm left with 15 plus 9 plus 12. I'm doing a little backwards distribution, right? We just did a quiz, had distribution on it, right? If I gave you this math problem on a test and I said, distribute that, 16, you would go 16 times 15, 16 times 9, 16 times 12, right? I'm just going backwards. I'm starting with the already done multiplication problem and I'm pulling out the 16. See what I'm doing? I'm undistributing. Does that make sense? What do these 3 numbers represent in our problem right here? But what do they represent in our problem? Of what? Of the triangular base, huh? Right? You see it? 9, 12, and 15. It's the perimeter of the base. So if we just take the perimeter of the base and multiply it by the height of the solid, we come up with the area of all 3 remaining sides, the literal area. We're not finding the area of the triangular base. We're finding the perimeter. Okay? That's why the lateral area formula works. Now, this is one of the things that I love about math is seeing these things and going, oh, that kind of makes sense there. Now I understand why. A lot of times when math is taught, it's just like, here, memorize this. Now do it. But if you can understand it, it's going to make it stick a lot better, okay? All right. So where I can do that for you, I will try to do that for you. All right, so we have our lateral area of 576. It's going to be meters squared eventually, right? Okay, so now we know that our surface area of our whole triangular prism is going to be our lateral area plus 2 times the capital B area of our bases. Now, Samir, we got to find the area of the base. Now we got to find the area of the base. What shape is the base again? Triangle. What's the area formula for finding the area of a triangle? Okay, 1/2 times lowercase b times height, which is the b that meets the height at 90 degrees. See why this is confusing? It gets a little tricky. Let's write that down here just to remind ourselves. So we're talking about the capital B area of the base is going to be equal to 1/2 times lowercase b times height. See my triangle area formula there? This comes from the test you just took, find the area of the triangle, right? So now these two, lowercase b and height, need to meet at 90 degrees. So what I want you to do is in your mind, I want you to isolate out everything except that part of the picture right there. Just get rid of all of it. Just don't even look at it unless you need the numbers, right? But isolate that out because what we're looking for in this problem right now is this area right here. We want to know what's the area of that shape. Find the B and H that meet at 90 degrees and put those numbers in here and here. Ready? Go. 9 and 12. Why 9 and 12? Because here's your 90-degree angle. That means that this and this are lowercase b and lowercase h when we're talking about finding the area of a two-dimensional shape. Does that make sense? Okay. So that gives us the area of one of the bases. So what is that area? Yeah, that's going to be 54, right? And there's 2 bases, right? So we have to multiply by 2. That's what that times by 2 is there.
So you have like a shortcut, like
Hold on. I know your shortcut. I'm going to answer that question in just a second. All right. So this is going to be 576 plus what? 108. Good. And then what are we going to get? $684 what?
meters squared.
Meters squared. Very good, because this is an area measurement. All right, Samir, go for it. What's the shortcut?
You don't have to divide by 2, right?
Why?
Because if you're looking
You mean here we don't have to divide by 2?
in like the formula,
Why?
because if you're getting 2 triangles, right? Like bases, find the area for both of them.
So what you're saying is by dividing by 2 and then multiplying by 2, I'm going to still end up with 108, which is 9 times 12?
Yes.
Okay. Mathematically, yes, that works. Do I want you to do that? No. Let me show you why, though. I have a good reason, okay? Here's my good reason. Watch, Samir, okay? I want to know that you know the area of the formula of a triangle and how to find it. I also want to know that you understand that there are 2 bases in a triangular prism. By writing it like that, you communicate in writing to me, I know I'm finding the area of a triangle, and I know there are 2 bases. Even though we end up with the same value here, your communication is more thorough. Just like writing an English essay in more detail. Okay? Make sense? Great question. Thanks for bringing that up. Okay. How are we doing so far? Okay. Let's try number 5. So what kind of a shape do we have here in number 5? Tell your neighbor right now what kind of a shape we have here in number 5. What kind of a solid do we have here? All right, we're going to say it out loud as a class. In 3, 2, 1, this is a triangular prism. Hey, we just did one like that, didn't we? Okay, very good. Then why don't you find the surface area by finding first the lateral area and then finding the area of the bases and then coming up with the total surface area. Let's see what you can do. Go for it. I'll give you 4 minutes to do this one. All right, ready, go. Highlight your bases too. Highlight your bases. Start by highlighting your bases. We're doing surface area of a triangular prism. Highlight your bases first. First, highlight your bases. I'll give you some steps along the way just to kind of check in with you. So start by highlighting your bases. So just make sure you're on the right track. Highlighting your bases, you should have gone here. Yeah. No, I'm not revealing everything. I'm just little checkpoints along the way. You're moving in the right direction. You should have been heading this direction here. 3 is going to be your height because that is the line that separates the bases, right? Again, remember that's your understanding of height is the line that separates the bases. That's the height of the solid, not the height of the two-dimensional triangle. That's a different height, right? I sent my kids out to play. I took my wife to see a play, right? Again, 2 different heights here. There's the height of the solid that separates the 2 bases, and then there's going to be the height of the two-dimensional triangle that we use to find the area. Okay, keep going. Here's a little checkpoint for you. Your lateral area should have gotten 81. Then you start working on your area of the base of the triangle, right? Now that's going to become from the flat two-dimensional surface, the triangle base. You're looking for measurements that meet at 90 degrees. That would be, like if I use this back green base, you can see that I have this distance here and this. Can you see that that's the same problem we just did? Right? That's the same question that we just did from the last lesson, from 0.2. It was, hey, here's a triangle. Find the area of that triangle. Oh, the height line's in the middle. The base line's at the bottom. Base and height always meet at 90 degrees in a two-dimensional shape. So then this is our base and height. Okay, keep going. Finish it up. Let's see what you can get. Here is our answer. 130.2 kilometers squared. How many people got that right? Let me see. Good. No, you didn't? Okay. Can you figure out where you went off the tracks to not get that? Take a look.
Oh, I didn't buy the base area.
Okay, there you go.
Wait, can you say it out loud?
Gotta say what out loud? Me out loud or somebody else? That's a great question. I want you to see if you can figure that out. If you can't, then bring me your paper and I'll help you figure it out, okay? Okay. Yeah. I'm sorry, is what 3 what? Yeah, the height is 3. Okay. Which height are we talking about? Which play are we talking about? Are we talking about my kids scampering around outside or the people up on the stage singing and dancing?
What?
Wait, hang on. Watch carefully. Watch up on the screen, okay? Here, let me change this color so it stands out a little bit more. Okay. The height of the solid is the distance that separates the 2 bases. That's the height of the solid. The height of the two-dimensional base is what meets at 90 degrees on the two-dimensional base. So if my kids go outside to play, or I take my wife to see a play, you have to be able to differentiate between the 2 different meanings of those words based on what math you're doing. Are you working on the 3-dimensional shape, the height that separates it, versus the 2-dimensional shape, the height that meets the base at 90 degrees?
I'll flip it over like this. 3 would be going straight, right?
It would still be a height.
I know, but like
it's still the height of the solid because so this is where the clarification comes. And if it's easier for you, look,
Like that.
Watch this. Okay. If it's easier, write this down. This is the distance between bases. Okay? So if it's easier for you to understand the height of the solid as the distance between the bases, if that helps you to understand that, that's fine. You can think of it that way. That's what it is. It's the distance that separates the two parallel bases. That's the height of the solid. That's my kids went outside to scamper around play. But then, when we're trying to find the area of the two-dimensional shape, this is the base and height. I took my wife to see the play.
Wait, do we have homework?
Yes, there's homework. Let's talk about what your homework is. We're not quite done just yet. All right, number 6, highlight the bases. Yes. Okay, good. Outstanding. Way to go, Lisa. All right, highlight the bases on number 6. Highlight the bases on number 6. Ready, go. Highlight the bases on number 6. Ready, go. Bases for number 6 should have looked like this. Okay. What is the height of this solid?
15.
15 feet, right? Good. Okay. All right, now, what kind of a shape? First name, last name? No, that's not a rectangle. That's not a triangle. That's a trapezoidal prism. You're going to need the area of a trapezoid, lesson 0.2. Okay, all right. So here's what you're doing for homework. You're going to do, watch, listen. You're going to do 2, 3, 6, 7, and 8. Okay? 2, 3, 6, 7, and 8. Quick, go to 8 right here. I want you to highlight this right here. Okay, I'm going to give you a hint on number 8. Ready? That's my hint. Oh, what is that?
The hypotenuse.
Oh, okay, all right. So you are not going to do anything below number 8. Okay? You're not going to do anything below number 8. You also have a few other problems to do on this paper. I'm going to tell you which ones to do, so have your pencil out and get ready to circle them. Yes, highlight all of your bases in every problem. In every problem, you're highlighting all of your bases. Okay? Highlight your bases in every problem. Okay? I'm going to tell you what numbers to do on here. Okay? You ready? Okay, get your pencil ready to circle. Circle 1, 3, 5, 9, and 11. 1, 3, 5, 9, and 11. Now listen, okay? Everybody eyes on me, real quick. Okay, I am going to complete for you 2, 3, 6, 7, and 8 on the notes. I'm going to do those on the video. And so when you do them and you complete them, go to the end of the video and check your work. Do them first, just like homework, but these answers will be there for you to check and see how you did. Then you do the other ones, and that's when we'll check and pop. Everybody got it? Yeah. All right, good job today, you guys. Way to go. 3D geometry, we're rolling. Nice work. All right, so I said I would show you the answers to the questions from our notes. So here's 2 and 3. Take a look. Should be pretty straightforward. Pause if you need a little bit more time. Okay, so 2 and 3. All right, I'm going to move on now. Again, pause if you need more time. Here we go. All right, so let's take a look at 6. How did you do on 6, right? Again, so we had to calculate that area of that trapezoid base, right? That's that capital B base trapezoid. All right, we have to find that perimeter up there to help us with the lateral area, and then we come up with this one. So again, if you need to study this and take a look at the answers and see if you figure out if you didn't get it right, where did you make your mistake, go ahead and pause. Otherwise, we'll move on. All right, here is 7. Let's take a look at 7. So 7, you can see over here, I calculated the trapezoid area. right? So I used, this is the height and base for the two-dimensional trapezoid. That allows me to come up with that capital B area base, right, that I can use in my lateral area formula, right? And in here for my surface area like that, right? So that's 7, and then here is 8. And of course, we talked about needing a little Pythagorean action going on here, right? To find this length, which allows you to find the perimeter of the base and then work your way through that. So there's 2, 3, 6, 7, and 8. And again, you can always move the video back and forth to check your work and see how you did. All right.